Hi guys, we have this question. So let me read the question. Determine the transfer function V2s over V1s given the figure below. So guys, this is our figure. And as you can see this figure, I will have to show you here, right here guys. This is the figure we are talking about. So in this figure guys, we are going to have the current flowing in this way. And as the current flows, we have the V1, which is our input, and the current will flow through R and through L, and then will flow through these capacitors. Across the capacitor, we have the V2, which is our output. And so guys, we are going to have two loops like this. We are going to have this loop, that is, we can call it loop 1 and loop 2. So we are going to have loop 1 being represented by V1, whereby V1 is equals to VR plus VL plus VC. And loop 2 will be V2 equals to VC. And this is what I have already done guys here, as you can see. You can see V1 is equals to VR plus VL plus VC. So converting that, guys, we have V1 is equals to, the equation for voltage across the resistant is IR, across the inductance is L di over dt, plus across the capacitor is 1 over C integral of I dt. Guys, for V2, this is what we have for V2. V2, we have voltage across the capacitor, which is given like that. From there, guys, we come to this now, to this equation here. The equation you see here, dq all over dt, is actually called, is the definition of current, where we say that current is the rate of flow of charge. And so therefore, guys, what we are going to do is to represent, because what we are looking for guys is actually V2s all over V1s as our transfer function. So we are going to express all these terms in terms of V2s or V2 before we go now to V2s. So guys, one of the term here we can write V2. This one is already V2. And now guys, as you can see here now, when we come here, we differentiate this side and we differentiate this side. Guys, we will have something like this. And so therefore, guys, we are now able, guys, now to replace for I, which is here. As you can see, I is dq all over dt. So guys, instead of us writing dq all over dt, we shall write dv2 over dt multiplied by c. Remember, when we bring c here, you shall have dq all over dt is equals to c dv2 all over dt. That is for I. Now guys, going to di dt, we'll need to differentiate again. You differentiate this side and this side. And in fact guys, you can leave this one alone. You just come here, differentiate this side and this side. And so therefore guys, we shall have something like that. So when we now put our c here guys, we can now be able to replace the di all over the dt with c d squared v2 all over dt squared. And that's what guys I have already done here, as you can see. I've now been able to replace the I. We had I, this is I, and guys, this is di all over dt. So that guys, I'll have each of these terms will have the v2. Then from there, we take the Laplace transform of both sides. And taking the Laplace transform, we shall have V1s is equals to RLC S Laplace transform of dv2 over dt is s v2s plus, for this one will be s squared v2s, and this one will be v2s. We can now factor out v2. factor out V2, guys, we are going to find it like that. And then this one is going to be, of course, this one has an S there. So from there, guys, we can now write this. This is what now we have. So V2S all over V1S is equals to that. And so, guys, this is our transfer function for that circuit. So, guys, thank you for listening to me. Bye.